Hello students, in this session we will learn average and instantaneous rate. Let us understand the average rate and the instantaneous rate by considering the isomerism of cyclopropane. Do you know isomerism? What is isomerism? Isomerism means the compounds contain same molecular formula but vary in different structures or physical and chemical properties, etc. Isn't it? So first is the isomerism of cyclopropane. Okay, so this is the example of cyclopropane. This is the closed component. Then at 780 Kelvin, this cyclopropane convert into the propane. Okay, this one is the open chain component. Okay, so here 1, 2, 3 carbons are there. Here H2 and H2. In this example also 1, 2, 3 carbon. Here CH3, then here CH2. Okay, same molecular formula, 3 numbers of carbon, hydrogen 6 numbers. Here also 3 numbers of carbon and hydrogen, 3 plus 1 4, 4 plus 2 6. Okay, so next one is the concentration of cyclopropane at various times during its isomerism at 780 Kelvin. Okay, so first of all we have to take a time in minute units. Okay, then cyclopropane, concentration of cyclopropane is mole per liter. When the time is 0, what about the concentration of cyclopropane? 2.0. Okay, then time 5 means it is changed into 1.67. 10 means 1.40. 15 means 1.17. In time 20, 0.98. Then time 25, the time goes to 0.82. At time 30, it converts into 0.69. Here we find it, the time will be increased and the concentration should be decreased. Here 0, 5, 10, 15 increases, but here in this concentration of cyclopropane order is decreases. First is 2, then 1.67, 1.40 like that. Okay. Therefore, during the time interval, the time increases and the concentration of the cyclopropane will be decreases. Okay. Therefore, the rate of the reaction is, what is the formula? Minus concentration of change in the concentration of the reactant divided by change in time. Okay. So here, what is the reactant? Reactant is the cyclopropane. Therefore, we take it minus delta concentration of cyclopropane because this is the reactant per unit time. What's the time? Delta T. Delta T means change in the concentration. Okay. Okay, first of all, we have to take the rate in the overall reaction. So 0 to 30 minutes. The rate over the entire 30 minutes. So in this overall reaction, so 0 to 30 minutes, isn't it? So we can to find out the concentration of cyclopropane is, the last one is 0.69. First one is 2. At time 0, 2 moles of cyclopropane is there. At time 30, 0.69 moles of cyclopropane. Therefore, what about the change in concentration? Minus 0.69 minus 2. Okay, because 30, in time 30, we get the 0.69. At time 0, we get 2. Okay, therefore minus Why we put minus here? Minus means here the concentration of the reactant is lesser, decreases. Therefore, we put minus symbol here. So the rate over the entire 30 minutes is equal to minus 0.69 minus 2 mole. Then what's the time difference? 30 to 0. Okay, therefore 30 minus 0 minutes. Okay, why we put here minus? Because the time is taken in the minus unit. Okay, therefore we get 4.36 into 10 power minus 2 mole per liter per minutes. Okay, then the rate of the initial stage. Okay, so here we have to take 0 to 10 minutes. Okay, so the time change in time is 0 to 10, therefore 10 minus 0. Then concentration. Okay, so here one correction is there in your book. Minus 2.0 minus 1.4 is there. Okay, you can change it 1.4 minus 2. Okay, because we have to take this to this one. Okay, therefore 1.40 minus 2.0. Okay, therefore we get 6 into 10 power minus 2 mole per liter per minutes. Okay, then later stage. So here in this later stage we get 20 to 30 minutes. Okay, then out of the time variation 30 minus 20. Out of the concentration variation 0.69 minus 0.98. Okay, therefore we get here the value is 2.9 into 10 power minus 2 mole per liter per minutes. Okay, from the above calculation we come to know that the rate decreases with the time as the reaction proceeds, and the average rate cannot be used to predict the rate of the reaction at any instant. Okay, the average rate cannot be used to predict the rate of the reaction at any instant. Therefore, the rate of the reaction at a particular instant during the reaction is called instantaneous rate. What is instantaneous rate? The rate of the reaction at particular instant during the reaction is called the instantaneous rate. Here we have observed the rate decreases while increasing the time. Okay, therefore to calculate the average rate, it is impossible to explain this. For this, next we have to calculate the instantaneous rate. Okay, before going that, we are going to simple graphical view. Okay, this is the graphical representation of concentration of cyclopropane versus time. Okay, so here when the delta T is equal to 0, the instantaneous rate at a particular instant T, therefore we have to take minus D. So initially we learned minus delta. Okay, so now as minus D, concentration of cyclopropane per dt. Okay, is obtained by calculating the slope of the tangent drawn to the curve at any instant. Okay, that is the tangent. This is the tangent view. Okay, at any instant. In general, the instantaneous reaction rate at a moment of mixing the reactants is calculated from the slope of the tangent drawn to the curve at mole per liter. The rate calculated by this method is called the initial rate of the reaction. Okay, Let us calculate the instantaneous rate of isomerism in cyclopropane at different concentration. Okay, so first of all, when it is value, cyclopropane value is 2, the rate is 6.92 into 10 power minus 2. Okay, when the cyclopropane concentration is 1, the change into the half of the value. So we get 3.46 into 10 power minus 2. Okay, then when it change into 0.5, the concentration is 0.5, we get 1.73 into 10 power minus 2. Okay students, this is the average and instantaneous rate. Okay, hope you have understood. Thank you.